Hello, everyone. Welcome back to our open course. This is our fourth lecture. And in last lecture, we talked about T-type three-level system. And this time we will go to I-type three-level system. If you didn't watch our last video, I strongly recommend you firstly take a look, then you can have a general impact about it. So let's go into today's lecture. Hello everyone, welcome back to the open course by Firstack. Today we continue our topic of double pause test in three-level system. In last course, we have already discussed T-type topology, and this time we will introduce I-type system. They are quite similar, I must say, but the topology and our faced problem can be more complex. But if you have already impacted in T-type, I believe you can understand I-type much easier. Okay, let us start from our catalog. Today we also have these 4 chapters. The lecture is divided in 2 parts. At the beginning, I will go through the first 2 chapters, the applications of it and the operation status, so we can have a general impact on I-type system. And in the second part, I will introduce you how to process the double pause test and SC test. Now we start our first chapter, the 2 different applications of I-type system. The first application is low power application. The power level is around 5 to 100 kilowatt. Now in the market, you can find this kind of modules, for example, EasyPack and EconoPack. The topology of them are similar as shown in this left figure. There are totally 6 components in it, T1 to T4 for IGBTs with their corresponding diode, and the DC1 and the DC2 here in the left are our clamping diode of our input voltage in midpoint. I will explain how it works later in the coming part of this lecture. So this is low power application. Then you will have a question, how about higher power application? At this time moment, we don't have a single module solution. For the power level up to like, for example, 500 kilowatt, then we have to use the combination of several single modules. We can go to this slide. As we can see, there are 3 different types of module combination of high power application. The first one on the left, we can find that this green and red areas represent actually 2 half bridge. As we know already that in a single module like EconoDual package, the half bridge is included in it. Therefore, it is just like we connect 2 single modules here together. And in order to provide a freewheeling path, we add this extra half bridge here in left. In this blue area, the topology shows only these 2 diodes, DC1 and DC2, but actually there are 2 complete IGBT here. Just take a simply minded view for you. And if we look into this figure in the middle, this is another possibility. We didn't take T1 and T2 together as one, but we take T1 and this DC1 together as one half bridge. And also here DC2 and T4 together, and T2 and T3 are now combined as a single module here. So we still use 3 modules combined together to build this I-type system. And the last possibility shows in right figure. This one is a little bit different. We use here only 2 single modules, but inside of them we put DC1 and DC2, so we can still build the I-type system by only 2 modules. The benefit of this kinds of design is that our current carrying capability is greater than before, which means at the same time we can create a higher power output above 500 kilowatt. And also, I have already mentioned in last course some of benefits of three-level system. Here for I-Type, there is a very special benefit of it. Is we don't need to use modules for 4 DC voltage, but only half of it. If you look into this topology carefully, you can find that the half bridge in the green area only take the half DC voltage, and the red area takes another half of it. So as you know, normally higher the voltage level of our module, then greater the price of it. For example, if you use a 2400 volt DC voltage system, by two-level system, 3300 volt module is necessary, but in three-level system by I-Type, only 1200 watt module is enough. Even you use 3 of that, the total cost is still lower than a 3300 watt module. So this is a great benefit for us by I-Type system. Okay, this is how we build I-Type three-level system, both in low power application and high power application. Now we go to our next chapter, which is about the operation status. I make a logic table again in this slide. If you look at it carefully, it is quite similar to T-type logic table. We have for IGBT T1 to T4 and for diodes, but pay attention, here we test D1, D4, DC1 and DC2, not D1 to D4, and also other two capacitor banks, C1 and C2. Why D2 and D3 won't be tested during the test? This is because when we turn off T1 or T4, these two diodes won't participate in reverse recovery process. I will explain why later in the third chapter during the introduction of the double pulse test of it. Okay, let us go back to this slide. 1 is still turned on, 0 is off. So this is also same like T-type logic table. But you can find a problem of I-type system. Let us think about it. Now we are in, for example, in the status 3, the status bit 3 here. And we want to go to status bit C. So in status bit 3, T1 and T2 are off, T3 and T4 are on. Now we need to turn on T1 and T2 and off T3 and T4. Then there is a question. When we turn off IGBT, which should be turned off first? Because you cannot turn off them at the same time. It is not allowed. If you search the related document in the internet, everyone will tell you the external IGBT must be off first. But why? If we take a look in this slide, this two topology, you can imagine when T3 and 4 are on, the current will flow through them, flow through T3 and T4. And now we turn off T3 first and keep T4 on. You can see in the right figure, the current will flow through this blue path. And the voltage level of the collector of T3 now is DC plus, and the emitter of it, because now T4 is on, the emitter of T3 is connected directly to DC minus, which means T3 offers a full DC voltage, not half of it. And I have already mentioned above that for I-type system, each module are chosen based on half of DC voltage, not full of it. Therefore, there is a risk that the module will be damaged by such high VCE voltage. Therefore, we must turn off T4 first. Now you can see that the voltage level of the emitter here of T3 now is 0, which means T3 takes only half of our DC voltage. This is the exact correct control logic. And for T1 and T2 is the same. We must follow the same control logic. Here we turn off T1 first and then T2. So this is a switching sequence of I-type system. Okay, now we finish also this chapter. This is a basic introduction of I-type, includes the operation status. In next chapter, we will discover how to do the double pulse test and also the SC test. So see you in our next video. Bye.